the game class is the workhorse of our engine. And because this is where we deal with the game's state and basically do all work, this is where we have to deal with the Android lifecycle as well. I'm just going to shut up for a short while, write out a couple of members, and then we'll talk about the details of how this will work. So the first thing here is a static field belonging to the class. This is customary in Android development. We create a tag so that we can tag debug messages from our classes. If you create a custom class, always create a public static final tag with the name of your class. Then I have the game thread, which we're going to use to execute our core loop. And we need a flag to let the thread know when to stop updating our core loop, stop running it. So the way that's meant to be used then is, for as long as we are running, execute all steps of the core loop. These, of course, are not implemented yet, but we can uncomment those and get some warnings, so we get around to fixing them. We take input, we update the game state, and then we render the game state. Always in that order. Don't throw them around. We want to take input first, update all the state, the physics, the velocities, integrate, do the collision testing, all of that, and then render the fixed state to the screen. The question now then is, when is the thread going to start? Because right now it's undefined. And how will we change the isRunning flag? And the answer is, we're going to do that in response to the lifecycle callbacks. So if you go back to the game activity, we have our commented function calls to game on resume, game on pause, and game on destroy. Those methods don't exist, and because I'm super lazy, I'm just going to copy these declarations and bring those back to the game class, and then remove some arbitrary bullshit. We're not inheriting from an activity, so we don't have these from the parents. I'm just going to grab, actually I can empty them entirely. There we go. I just needed the names. So we have an on resume, on pause, and an on destroy. So on resume, that's where we know that our application is on top and in front of the user. So what we need to do here is create the thread, set the flag, and start the thread. Then in on pause, we need to join the thread and, well, we need to reset the flag and join the thread. We also want to log this so that we know what's going on. And the way you do that is you bring in the log. You can do a debug log. There are other types of logging commands here. You have for errors, for information, for whatever. Most of them take the tag and then a message. So in this case, I'm just going to call, print out on resume, so I know this has happened. All right. What I need to do is first set isRunning to true, because that's what we want to happen. Then I want the thread to be created. The thread needs the object on which to execute a run callback. So that's this. And then I need this thing to start. Game thread. No, okay. That's misspelt. Jesus Christ. New keyboard, and we're not friends yet. That should get us running. Then we need to stop somehow. We're going to do the same thing here with log. On pause. I'm also going to log on destroy, so might as well bring that in here. We set isRunning to false. Sorry, isRunning. Then we need to wait for the game thread to join, and that might throw an exception, so we have to do that within a try statement. So we do game thread join. This is basically going to wait for this loop to go through so that it can check, so that it can check that the flag has been reset. We will exit the loop, exit the run method, and then it'll let go of us so that we can exit this method. Then we need to catch the error. That's it can throw an uninterrupted exception. Let's see if we can generate that. Add catch clauses. Perfect. Much easier. And we don't care if this happens. There's nothing we can do about it if it happens. And we also just, like, we're going to leave the application anyway. So we might want to print this. You might actually want to log it the way you're logging everything else. So you can do log with your tag and then do something. Let's see. You can get the stack trace from the error object, get cause. That's way more verbose, obviously, but this puts you in the same category of log, so you can filter this out automatically when you don't want to listen to the game object anymore. So either way works, whatever you care about. The point here really is that if you ignore a caught exception, if you're not going to deal with it, you need to log it or leave a comment in your source code that you're doing that intentionally. So in this case, I'm just going to keep it this way. Now in onDestroy, we really don't have anything to do, and I guess what I'm going to do actually is I'm going to set the game thread to null. Because I created the game thread, I want to make sure that I've destroyed that reference as well. This is unnecessary, it's just a habit I've gotten into. Later on, if we have the audio implemented, we might want to call onDestroy on the audio object, so this can be useful later on. Okay, what do we have? We have onResume, set the flag, start the thread. We have set the flag in onPause to false and then join, so that should stop executing. So lastly, we just need the core methods implemented. So let's make those private void input and maybe, you know, a function body. I'm pretty sure we do not need input, update and render. There we go. So what needs to happen? This is going to be update the state of all entities and the player and the game world and so on and so forth. For rendering, we are in a surface view. So first we need to acquire an access to the buffer, to the actual surface. So first we need to lock and acquire it. Then we need to draw to it. And then we need to unlock and post the surface. Entities. Just so that I have a to-do list here in my head. Yeah. Interesting fact when we get around to this is what we're doing is reaching fairly deep down into the Android API here. The surface is basically a raw frame buffer. And we lock it so that we can edit it in any way we want. And then we unlock and post it, which means we have rendered to it and then we give it back to the Android UI thread to draw whenever it gets around to it. The UI thread is executed 60 frames per second. As a callback, comes into all apps. And when we post, we're actually going to wait for it, which means we are effectively locked into 60 frames per second here, for as long as that's true for the Android operating system. If you want your game to update faster than 60 frames per second in this model, you have to move the render call out of this loop and put it in a separate thread somewhere. So that this thread, the way it's done now, it would input an update, read inputs, and do the update as fast as it can. A game as simple as ours might be able to update 2,000 times per second, but we have no benefit of that. In fact, being locked into and synchronized with a UI thread, we can do all the work separately, so we don't slow down Android, and then we just give it a finished frame buffer to put on screen. Being locked into that pace saves a ton of battery time, right? It allows us to use the small cores or to do very little work on the CPU because 60 frames per second is not super frequent. It gives us 16 milliseconds per frame to do all of our work, and most CPUs on a phone today will be able to do that easily. And so, yeah, there's a benefit to this model. This is what we need for the infrastructure. I'm just gonna make sure that compiles, and then I'll see you in the next video. Perfect. There we go. And back out. I can hear the fans starting there as I'm spinning an empty loop. All right, see you in the next video.